Hopefully you are seeing the current slides. Yes. Okay, cool. Great. So yeah, like I said, kind of if you caught that towards the beginning of this this meeting here, the goal here is that we are going to just give you the quick and dirty tool set to get you up and running with your own package. I think because I did a lot of prep work for this, I have like just some code already prepped. I don't think this is going to be the easiest to follow along with. I'm not doing anything creative with my code. It's just to try to help move things along because there is a lot to cover. I also want to like make it abundantly clear, this is in no way a substitution for Hadley's book, The R Packages. Think of this as more of just like the teaser, enough that you feel comfortable, but anytime you run into any major pain points or pitfalls, I would just refer back to this book to try to like iron out any of those creases. And so like, I think earlier we were hearing about like why people think they want to do an R package. There's a whole lot of reasons. There's a lot of benefits, whether it be collaboration, if you just are tired of copying and pasting code over. I think another one to think about though is just the very fact that it's very well defined and designed conventions. The way I think about it is, you know, I remember when I first learned R and I did everything in base, kind of just did things with just base R. And especially with ggplot, I was like, well, I already know base plotting. Why would I need ggplot? It's like, well, no, there's a lot of really nuanced things around ggplot that really extends the language. And I think if you get into R package development, you'll kind of start to see a lot of those benefits that we're not even covering right now. So this is more of like, if you're referring back to these slides at a later date, these are kind of the heavy hitter packages that you'll want to be able to like do what we are going to be covering today. What I recommend before we start off with any R package development is to edit our R profile. And so I'm going to go ahead and kind of do exactly this. So if you're using the use this package, there's a handy function in there called edit R profile. This might give you problems if you're on Windows, if your networking is set up a little strange, but for the most part, it should work. So what I did is I just typed in this code. What you'll see, what's great with use this is it tells you very succinctly what is happening behind the scenes. And so what it did is it created this .r profile, and it tells me, and it also automatically opened this up for me to edit. It also says, if I make any changes here, I need to restart my R for any of those changes to take effect. Okay, so there's, within the use this documentation, it kind of explains exactly why you should do this.
Dave, are you going to share your screen?
Is my screen not shared?
No, it is, Madeline.
I don't see it.
It's shared.
I see Dave's screen.
Yeah, I see it too. Yeah.
I see it too.
Okay, my problem. No problem. Sorry.
Okay, sorry to hear that. Hopefully you can fix that throughout the talk here. So basically what we're doing is we're just introducing ourselves to the use this package. The reason this is important is that whenever you spin up a new package, it just automatically pulls all of this information. So you're not just like redundantly typing this over and over again. And so what I'm going to do is go back to my slides here. I just went ahead and copied this or kind of rewrote this exactly how I like it. Obviously don't mimic me, but you know, hopefully it's pretty explanatory what fields should be updated there. So what I'm going to do is I just pasted that into my R profile. I'm saving it. And just like it said, for anything to take effect, I need to restart my R. I'm also adding DevTools and test that to my environment. These are pretty much the only packages that you'd want to do this on, because the way that you should think about these are the two kind of meta packages. They are packages for package development. You should never be calling these packages in your code short of doing package development. Another thing to kind of keep in mind here is that DevTools is, in fact, it encompasses use this as well. It's kind of like a tidyverse framework, except it's a little bit more under the hood. Okay, great. So looks that's a little concerning that it's taking a second there. So I'm just gonna kind of keep switching back and forth between my presentation and RStudio here. And so what we want to do before we even start on, like, you can do this at any point, but it's just way easier to do this up front, is we want to land on an effective package name. And so what we're going to do is, oh, sorry, 1 second. I just realized that restarting my R would impact the presentation there. That's my mistake. And so what we can do is use the available package. And so whenever we use the available package, what it's going to do is actually scan through CRAN. It's going to scan through Bioconductor, GitHub, and just also, if maybe your English as a second language, it's going to look up abbreviations, Wikipedia, Wiktionary, to make sure that you're not unintentionally using an acronym that is offensive in any way. So it's just like a really nice to have package to just double check it. For the sake of this talk, we'll just be making a Lord of the Rings themed package. It's all arbitrary code, but we'll be naming it Grond, which is a battering ram from Lord of the Rings. So what I'm going to do is just go ahead and start by making a blank GitHub repository. And I'm going to be cloning this into my RStudio session. Okay, so we just created the GitHub repository, and now we just need to check out that there we go. If you just give me 1 second. What we're doing is I'm just creating a new repository on my RStudio to just take this in and just basically start from scratch here. And so what you can see, I am now in a brand new project called Grond, and there's nothing in here. And so now to start on your journey for package development, it really is just this function here within use this, create _ package. And so what our packages recommends is that you do this before doing GitHub. I just prefer to do it GitHub first, then the package. It really is up to you. Because this is an empty thing, it's going to tell us that you're already in a project. And if this was another project that was filled, you'd have an issue. I'm just going to go ahead and say that we are okay to do it. And it's also going to say, hey, we already saw that you have a .rproj in this directory. We need to overwrite that and let RStudio know that you're now in a package. Again, I'm going to say okay. And what's nice is it's going to actually spit out a brand new R session with basically the bare skeleton of what a package is. So what we see is that we have an R directory. This is where our scripts are going to go. And then a namespace and a description file. And then we'll also have a .r build ignore file. So namespace and description, think of this as more of, the description is kind of more of the metadata of your own package. Namespace is how it handles, we don't want to just write a package using nothing but base R. So namespace is going to help you handle any dependencies. And then finally, build ignore is whenever you are building a package, there will be things that you need to do that you don't want to ship with your package. So that build ignore file is just a way of ignoring any sort of like structure that you need to help yourself build an R package, but won't actually be shipping with your package. Okay, moving right along. So yeah, like I said, the description file is where we are going to kind of start off. And so what this is I think if we look at what use this gave us, it kind of gives us just out of the gate at least some of that information. It also was able to gather my name because we already edited our .r profile. So we did that like nice handshake. What you can see, there's a few things that it says, hey, you know what, you're going to need to specify this. We don't know how to handle it. And so, for instance, the license, right now, it doesn't know what type of license you need, and you do need a license to have a package. These are all types of open source licensing. I think, you can explore that. For the most part, you should just be using the MIT license unless you have a reason. So I'm just going to go ahead and throw that in. And again, I'm using use this to do all of this, right? I'm not editing this file at all. I'm just doing it here. And you can see that it's kind of identifying that we're now in a package. It's creating a new license field as MIT and a license file. And then adding kind of some of these components to our build ignore. So this is like where use this is just incredibly useful, is because just keeping a mental track of how all of these pieces fit together is a little bit cumbersome. And if you mess up anywhere, you're going to get yelled at later whenever you try to actually build this package. So by using use this, we were just kind of able to, it's just like somebody doing some nice heavy hand holding along this path here. Okay. Another thing that I'll say is there's this, like, if your description ever kind of gets wonky or misformatted, you can always reset it with the function use tidy description. It's not going to change your description. It's just going to reformat it so it's a little bit condensed and in the right order. And then, as always, when you're doing package development, I think it's incredibly useful to kind of look at how other people have developed. I think we're all familiar that the tidyverse packages are incredible, but they're also incredibly sophisticated and complex, and probably shouldn't be our beacons of learning just because there's a lot going on that you wouldn't want to do right out of the gate. So I'm going to pick at the janitor package, which still by all means is complex, but I think the layout and understanding of how the package works is a lot more kind of in tune with what we're expecting for our first package. And so what we can see is, this description file looks very similar, where we see package title, version, who authored it, and then some of these other fields that we'll start filling in as we continue this journey. Okay, so we're going to have just like a very simple R script to start off. We are going to scrape this kind of terrible website that has a bunch of Lord of the Rings quotes on it. It's just not that great of a website, I'll be honest. Then we're going to clean and tidy that data. And then what we want to do is have a function that will just spit out a random quote from that list. So again, I already did this ahead of time. We're going to use rvest, stringer, dplyr, and tibble. And so most of this code is just doing the scraping and handling that HTML. There's also a whole lot of non-standard text. I'm forgetting what it's called, but we want to remove a lot of that and kind of just make this actually tidy data. And then finally, we're going to do that with a tibble. So we're making a nice tibble there. And then we are filtering based on whatever character we want, randomly selecting one of those, and then just pulling out the quote. So really, this is like really what we're interested in here, but this is our full function. So how do we add this to our package? Again, we're going to go back to use this. So what we're going to do is use the use R function. And let's call this, what I'm going to do is go use R, and we will call this quote Lord of the Rings, LOTR. And then I'm going to hit enter. And what you can see is that it automatically created a script under my R directory it opened it up, and now I'm ready to start editing on this. Because I don't feel like typing all of that out. I'm just copying and pasting it from what I have. And you can see we now have our function here. Okay, but I originally showed you, we've got a whole lot of calls here for like string R. This is an rvest call. We're doing some dplyr R and some piping. How do we handle that? So whenever you're doing your own package, you never do a library call. You don't do a require call. You handle your namespace a lot more intentionally. And one of the first things that we're going to recommend is, so as before, we just kind of have those function calls out there. We want to be as explicit as possible. And it looks like I missed one. So we're going to add stringer here. And we're just making each one of these function calls as explicit as we can. So I'm going to go ahead and copy this over to my R script. There we go. And so actually, this is probably a good demo of some RStudio. So let's say we've got 3 stringer calls here in a row that we want to make explicit. If we just hold down the Alt key, or maybe I think it's function on Mac, and then as we're holding that down with our cursor, we can just mega, like it's basically a mega cursor. We can type in string R : and it does that across all of those rows. So that way you're not doing the weird shuffle of Control-C, Control-V with the arrow keys. Okay, so we've got a nice function here. I mean, okay, it's truthfully a terrible function, but it is a function. We'll kind of get into why it's not the best on down the road here. All right, and so because we are trying to just get up and running with our code as fast as possible, I'm assuming that a lot of your code development is already just like using tidyverse. There's some significant nuances with using tidyverse within a package. So the 2 things that I'm going to recommend that you do are use the use pipe, because we're using pipes. I wouldn't really recommend doing the native pipe right now, because basically if you do the native pipe, you are going to require that anybody that installs your package has at least a version 4.1. And I've been, there's a lot of people that are still on like 3.6 out there. So, or even earlier. So unless you have an extremely valid reason to do it, I would try to still make sure that your package is as reverse compatible as possible. We won't get into that too much, but we're going to go over to our console. And again, we're just going to type in use pipe. No arguments needed. And what this is doing is it's now saying, hey, Magritter is going to be kind of part of our dependency list. It's also going to write a new R file that we don't have to worry about at all. And then it's going to say, to make these effects, we'll just need to document it. We can look at it, but again, this is just another nicety that use this gives you. You don't need to remember this. You just need to know use pipe, which is a pretty self-explanatory feature to remember. The other thing I'm going to recommend is the use package doc. And this is basically where I'm going to use it as a dumping ground for some of our package kind of documentation and nuances, specifically around the description file and the namespace file. So I'm going to use package doc. Again, no arguments needed. And all it's going to do is just create this grand-package, grand being the name of our package here. And you can see it's pretty empty right now, but there's like a nice handy set here where we can modify our namespace. And so if you are using a lot of tidyverse, this is just what I would recommend that you do right out of the gate. What we're going to do is make sure that we use rlang. So it's just some nice handy tools that kind of are how tidyverse kind of handles tidy eval under the hood. If you're not familiar, another thing is a lot of times when you're piping, you'll have the you'll just use the dot symbol. Our packages, kind of this construct of our packages was developed before that. And so it's going to say, hey, we're treating this as a variable and you've never defined this variable. So all we're saying is like, yes, we acknowledge it. It's what we're using for this framework. So I'm just, again, I already had that pulled out, so I'm just going to go ahead and save that. Okay. Okay, so now we are finally ready to run our code, right? And so we've got this quote LOTR. I'm going to go ahead and save it. And like how you typically run it is you either source it or hit run, right? Never in package development. So instead, what we're going to do is rely a lot more on kind of the like, this is where RStudio as an IDE really helps you out. And so what we're going to do is run DevTools load all. You can also hit Control-Shift-L. I think these I know a lot of people aren't big on keyboard shortcuts, but like I will say that some of these keyboard shortcuts are just way easier because you will be doing them so often. And so it might feel clunky at first, but I would recommend you start using these keyboard shortcuts because these aren't things that you'll just be doing once. You'll be doing this over and over and over again. It's kind of like a cyclic workflow. So I'm going to hit Control-Shift-L. And you can see what that did was it automatically loaded in DevTools : load all. And because I'm already in a package, it's just defaulting that to the current project directory. And now it's got our function in here. So why don't I do quote LOTR and we'll just get a good quote from Gandalf here. Yeah, that's a little long, so I'm not going to read it. And so the idea of how you, like, this is the core of package development workflow, is that it's just this complete cycle. I actually ripped this off of, I think, either Jenny Bryan or Hadley Wickham. So full credit goes to them on this. But you should reload your code, explore it in the console and make sure it does what you want it to, modify that code. And then once you're comfortable with those modifications, just go back to reloading it. So we're never sourcing it. We're never, at no point am I going through sections and running this into the console. We are only doing it through Control-Shift-L. Okay, so another nicety about package development is that there's some tools that kind of indicate, hey, is this a successful package? And so what we're going to do is rely on DevTools here to check our package. So whenever we do a DevTools check, it's essentially running an R command check. There's some nuances and differences there, but I think for the sake of what we're doing, just treat it more or less the same. So what it's going to do is make sure that it can be installed, and are there any weird issues with your package? So I'm going to go ahead and run a DevTools check. Because I have DevTools in my environment, you can see I'm just going to go ahead and run it. And I'm going to go ahead and tell you it's not going to like what we've done. Okay, great. This is what I was expecting. It's telling us that, hey, we noticed that you're using rlang and it's not stated as a dependency. So whenever you do an R command check, it should be giving you either errors, warnings, or notes. Ideally, I would say you certainly want 0 errors. You really, really want 0 warnings, and ideally you have 0 notes. You can pass with 0 notes, but if you're going to submit to CRAN, I think you need to really consider what's going on under the hood and is it addressable. Right now it says we have 1 error. I know we would have more than that. It's just errored out as soon as it got to the first one. And so it's saying, hey, we don't know, like, you're using this package and you didn't account for it. And so what we're doing is, again, use this as kind of thought this through. Normally, we would have to modify the description file and the namespace. If we just use package, and then it's saying it's complaining about rlang here, what it's going to do is add that to the imports field in the description. So if we go to our description file, oh, there we go. I'm sorry. Wasn't thinking straight. If we go to our description file, you can see that it's automatically added Magritter and rlang here. And then it's now saying if we use rlang, just make sure to explicitly call it. Cool. So why don't we go ahead and we fix that one? Why don't we do a check? And I know it's going to tell us we've got other packages to account for. Okay, so it's saying that we are also using dplyr, rvest, stringer, tibble. So pretty straightforward. We are just going to do the exact same thing for all of these. Unfortunately, I don't think you can pass a vector of these. So we'll just bash this out real quick. All right, that's simple. So now let's run a check again, and hopefully you saw in my notes to check early and check often. That's exactly what we're doing. I know I just addressed the things that it was warning about. I just want to verify that's exactly what was happening. And so you can see it's churning through that. All right, so we still have one warning, and that's because I had to do some cleaning around I think they're called smart quotes because that's what the website was using. There's a ways around it, but we'll address that kind of later on, and this will soon become a non-issue without us having to do too much extra work. Okay, I'll just take a quick pause. I know that's a lot, so does anybody have any initial questions here?
Not a question yet, but just curious if you're going to cover it at some point. And if so, just table my question. But I saw that you had a utils pipe script or, document for the package. What if you wanted to use sort of like backend functions that are really not intended to be exported for the end user, but you want them to be used for your package development? And where I'm going, because you taught me this trick, is to create kind of a utils script.
Yep. Yeah.
Cover that at all or not really?
Wasn't really planning on it, but we'll kind of dip into that, and we can talk about when you would want to do that.
Okay. Yeah.
And that's going to be handled way more with Roxygen, which is what we're just about to talk about. And so Roxygen is kind of the de facto documentation engine behind packages. And so again, to do this effectively, I would recommend you read the chapter here. Your Roxygen is always going to start like most code. Whenever you comment it out, it's just the hash bang here. We're going to do the hash bang and apostrophe, and that indicates that you're writing Roxygen. And to do this,
one question in the chat: what does use package doc do?
So use package doc is a great question. So all that's doing is it just automatically creates this grand dash package, and effectively it doesn't do anything unless we add stuff to it. And what I'm doing here is just adding two lines of code, 5 and 9, to basically say, hey, we're going to be using a tidy eval framework. And just that's pure. If we were to eliminate this, the command check would be barking a lot of errors at us. These are actually kind of tricky to troubleshoot. So that's why I wanted to just do this up front, because the language is not it's not the most intuitive, if I'm being honest.
I have a question around that, if you don't mind. So this dot data, so when you pass a particular, let's say objects to a function, and usually when you write a function, let's say in a package, you can preface the variables of that, let's say tibble that you're passing it as dot data and then $, the colon. So doing it this way gets rid of that necessity to call dot data on those things.
You could either do it, you could do it either way. I would actually recommend doing it .data, because again, you're just being a lot more explicit there.
Yeah.
If you are maybe collaborating with people and you don't trust that they do that every time, this will just, and here, you know what, we'll, why don't we just get rid of this and I will show you what happens when we do a check.
I mean, I prefer explicit as well, and thankfully I'm working on the package on my own, but
Yeah.
but for my understanding of what this is doing.
That's all it's doing, is just helping out with the shorthand. And so, yep, you can see I've already got a note generated there. No visible binding for global variable period.
Mhm.
And that is because in my quote, I think at one point, I'll admit this is sloppy, but I didn't, this is more for kind of the idea here is that we're taking a raw functioning R script and trying to make it into a package with like minimally altering that R script.
Yeah. Okay, appreciate you answering that. Sorry for the diversion.
No, that's a great question. I am going to go ahead and revert that, but that's good nuance there. Okay, so the four main Roxygen tags that you'll be using are export, and this is exactly what Javier was getting at earlier of like, how do you have internal functions that like help your wrapper functions actually do what they're supposed to within your R package without being exposed to the end user. This export tag is essential for your Roxygen of, do you want the end user to use this function? If you don't have export in your Roxygen for a function, the end user just won't be exposed to it, and unless they know where to look, they won't see it. The other ones that are always helpful, although they're not technically essential, but like, it's a good framework and a good habit to be in, is your params. So that's where you would kind of describe the parameters and arguments of your functions. Return, which is going to be describing what that function, if you were to run it successfully, what does it return? And then obviously examples. It's always nice to see like what that function in action actually looks like. So what we're gonna do, that's again a whole lot to remember, and being able to get that right out of the gate might be a little bit tricky. RStudio is super helpful here. If you just go to the top menu, code, insert Roxygen skeleton, and I'm going to show that in action here. So we are in our function here, quote LOTR, with no documentation. I'm going to go to tools. Actually, I just did that wrong. We're going to go to code. Sorry about that. We're going to go to code, and then you can see insert Roxygen skeleton. There is another keyboard shortcut there, but to be honest, I don't use this one all that much. And what you can see is it just automatically populated this function with some a Roxygen skeleton. It's even clever enough to see that we have a parameter character here. So it's already extracted that out of your function, and it's going to set you up for what you need to do. Again, this is a skeleton, so we need to fill stuff out. So why don't we... Oh, I guess I did not write this one ahead of time. So we'll just call this quoting word of... So this is all just like basic stuff, but not a whole lot. And the export tag, I do want this to be a function that my end users are going to be actively using for whatever reason. So we will add that there. And then my example would just be quote LOTR, and we'll just stick with Gandalf because that's easy to remember. Okay, great. Again, I'm going to pick on janitor again so that you can kind of see a little bit more of a complex Roxygen, but not being overly complex. So you can see that we have a title, all of our parameters listed, what it returns, and then they do a little bit extra with this family here. But then you can see they have kind of examples, and they are exporting that function. You can also write Roxygen for multiple functions on the same .r file. This is where I would read Roxygen 2 to kind of figure out what makes sense for you. But yeah. Cool. So moving right along, to actually get this documentation so that you can actually search it, you need to run DevTools document. And so we're going to, again, just run the command here, because this is, again, another iterative process. It's going to be Control-Shift-D. You can see that it's running DevTools over here, and it's now written everything. So what's nice about that is now if I were to run, so again, I'm loading it all, and if I were to check what is, which I don't know if this is, oh, it does, great. So if I'm like wanting to see what that documentation looks like, I can do it the old-fashioned way there, and you can see it's a very limited doc, but it kind of does show you what it looks like. We'll even run the example. Nope, no, shouldn't have done that. Okay. So there's a lot of nuance around like how you should shape and frame your functions, but I think I definitely want to talk about testing here, because I think it's probably the most underutilized component of early package development, and I think it's one of the most useful. And so the idea here is that like we want testing. I think they did a great job of designing test that to be kind of fun, and it really does feel good when you come back and it says all of your tests have passed. And so what we're going to do is show you just real quickly how easy it is to write tests. So we are going to work on the quote LOTR function. In the console, if we use the use test, it works perfectly because it recognizes what file is currently opened. So we're just going to write use test with no arguments. And you can see it's recognizing that we're in quote LOTR. So it's going to go ahead and just automatically generate test dash quote LOTR. It's also adding a whole lot of the structure around test that, that again, you don't need to memorize. You can just run those functions. This is the default one. It's pretty silly to make sure that multiplication works. But if you do want to run through your tests, you just hit run tests and it will show you whether they've passed or failed. You can also run DevTools test in the console. That works as well. So I wrote some quick tests here that I'm going to paste over. You'll see that I'm using the wither package because our function by design is random. And so I don't want it to, I'm testing that it works expectedly, right? And so if the result is random, that makes it very difficult to test. I also don't want to set the seed and like maybe that messes up all of my functioning moving forward. So what's great about the wither function is that you're setting the seed just within your test. As soon as that function runs, it unsets that seed. So you're back into a normal environment. Wither is just an incredibly powerful when you're doing nuanced testing within your own package development. And so what I'm doing is I'm testing that it's actually quoting Sam Gamgee, and then I also want to make sure that if I type in the wrong name, it errors out. And so again, I'm going to go here. I already pasted that over. I'm going to run DevTools test, and you can see that it's going through it, and it sparks joy, right? We have 0 failed, 0 warned, 0 skipped, and 2 passed. This is actually a technique for development, and I actually really love doing it this way. Is when you are close to being done for the day, but you want to do something, you know, I want this function to work say there's no argument passed. I just like, I still want it to work and still behave and just return a random quote from anybody. That's not functionality that I've currently built in yet. So what I'm going to do is just say expect, I think there's type. So I want to expect that if I were to type in quote LOTR with no argument, it would return a character. And right now, if I were to do this, it's going to error out. And so this is kind of like test-driven development. I now have a bench, like a goalpost for when I come back in here the next day and I'm like, oh, this is the feature that I want to work on. Now I know like exactly what I need to do, and the test will pass once I accomplish what I originally set out to do. So I would recommend doing some test-driven development. I think it's a pretty fun way of doing package development. Okay, I know we are at time, but we also started a little late. So I still am kind of jazzed and like want to keep going, but I also want to be respectful of everyone's time. So why don't we pause just real quick? We haven't done the two things that I want to do left are kind of how do you add package data and then vignettes and package down, which to be honest we only have like 3 more slides, so it's not that much more. That being said, it is that time. So are there any questions or kind of thoughts here?
Keep going.
Yeah, keep going. If John, if I'm host, if you could pass that over, if you need to leave, I can stay on too, just so we get a full
Nope.
recording.
I'm all good.
Okay, cool.
Thanks,
Cool.
Mike. Yep.
Thanks. Yeah, if
Okay.
anyone wants to drop, thank you very much for attending. If you're local, really hope to see you at our in-person meeting in February. But yeah, Dave, feel free to continue.
Cool. Okay, so kind of as we talked about before, this is where we're kind of thinking more about package design a bit. Our function is kind of garbage. Why are we pinging a website every time we just want to quote? That these quotes aren't changing, right? They were written years ago. So why don't we just create package data to pull that once into the package, and that way our end user never does this. I'm also sure that like the website design would love like thousands of users not pinging their site over and over again. So what we're going to do is write this as package data. And it looks like I'll have to edit this because it looks like my columns overlapped on my Quarto doc here. But the function that we're going to do is just use data raw. And you can use kind of, again, looking at the R packages, you can kind of see what's happening with package data if you want to learn a lot more nuance about it. This is not ideal for large data. This is meant for very quick, small data that you can easily ship with your package. So if you're getting into like over 500 megabytes, you're kind of setting yourself up and your end users up for failure. Okay, so what I'm going to do is I'm going to write use data raw. And so I am going to call that, we'll just call it LOTR data. And so you can see it just did a lot of that framework for us. It created this new directory. It also said this is going to be in build ignore. So any scripts we run in here will not be exposed to the end user. The reason we're doing this is because like, if we ever do want to make modifications to the data set, we kind of have a breadcrumb trail of how we got to where we are, and we can kind of recreate that data set. And so what I'm going to do is go to my function here. I am taking out everything about rvest, string R, and creating that data set. And now our function is doing the small nugget of kind of data wrangling that it's meant to. And then I'm pasting that over here. And you can see whenever I use the use data raw function, it automatically created this use data kind of call at the end. It is expecting whatever script you add here is a like whatever data set that you had defined it as, and that it will just override it. So this is the one part of a function that we will, or one part of a package that we will source, and we are just running this. And now you can see that we've created a data file. It's doing lazy data evaluation. And so, yeah, we are good to go. So before we continue, I do want to say that, like, so it does mention that you need to document your data. Data documentation is a little bit special use. So basically, what I'll fix the format here, but what you're going to do is just run use R data, and then you'll just copy and paste kind of this type of format, which is exactly what I did over here, where we are just describing what is in that data set. Yeah. And I think ggplot actually has some great examples of this if you do choose to look into that. All right, let's go into a vignette and a package down, which are kind of hand in hand. So to use a vignette, it's going to be just use vignette. You know, it's going to be an R Markdown, but with some special YAML at the top that you do not need to edit. And then we want to install and build our vignettes, and then we'll do kind of a final check here to make sure that everything's looking all right. Yeah, so I will do DevTools. Use vignette, and then we will say this is add LOTR to your code. It's use this, not DevTools. All right, and you can see it automatically created a .R Markdown with the special kind of YAML file that I was talking about, and then some just like very basic code here. This is where I'm going to use ChatGPT to kind of cheat, where I already generated this. Okay, so we are just going to copy and paste that over. Cool. And so what we've done is we've just written like we're saying, hey, here's a boring function. You can spice it up with this grand by adding quote Lord of the Rings into your, like whenever your function successfully runs. Don't ever do that. That's like super obnoxious, but you know, just a point, just an arbitrary example. Okay, so what we're going to do is, I think we're comfortable with that. We are going to load the package. Let's do a quick package check, make sure that we are in a good spot. All right, we've got a warning. That's because we've just added tests into I forgot that we did add wither into our tests. This is like one of those times where I'll say use suggests, but we won't get into that. That's a whole can of worms. I think that's like some follow-up reading, but typically just use imports. All right, and now we should be able to have like our full package. So I guess let's go ahead and build the package down. So we want R to know that we are running a package down here. So it adds a package down framework. Since we've already done everything with Roxygen, vignettes, we've done everything with use this, it's actually very streamlined. So we are set to just go ahead and build the site. At least I think this will be a moment of truth here. Oh, I guess we did forget to install the package, right? So let's go ahead and install it. And now let's build the site. All right. I mean, obviously we should add a README and make this a little bit more robust, but like at least the framework is here. If we go to references, we do see all of those that Roxygen that we defined. So we can go to the Lord of the Rings data set and see what's inside that. We can also go to quote Lord of the Rings. You can see that the example ran here, kind of how to use that function. And then even our article is already here. So yeah, it's not like, again, not the most robust package. We could, I think that the next thing that we'd want to do is build out a README so that the landing page doesn't look quite so bleak. But otherwise, like we have a successful package. Yeah, and you can see in our vignette how it actually runs. Like this is our normal function that we wrote, Fahrenheit to Celsius. If we did a fun Fahrenheit to Celsius, right before it gives you the answer, it looks like it gave me a quote from Gandalf there. So yeah, that is it.